Yeah, we have enough light. Cool. So this is a live reading using LabVIEW, showing the light and lux. Our humidity is constant right now at 32% relative humidity against the room. Temperature sitting at 71, and right now there is no soil moisture reading because we don't have the probe in the plant. But are you going to demonstrate that?
Sure, yeah. So soil probe goes in, and then
The plant is really, really dry because my roommate doesn't water a lot.
this is your cue soil sensor.
Is it like deep in there?
And
Bottle of water.
this is annoying. Oh, there it is. Okay. Can you guys hear the little trickle? Yeah. I'll wait, and hopefully it'll do it again here in a second in the next loop.
But basically we've got it set if it reads the soil moisture below a certain threshold that we put in. It will water for how many seconds?
Right now it's set to 2 seconds of running the pump, and so that's something that you can, again, just set up for your own needs. Is if you have a plant that's way bigger and decide that it needs to be running for 45 seconds before it's full or adequately filled.
Forgot to mention, this is a basil plant. They do not thrive well in the winter, so that's why it's ideal for something like this controlled environment box. So I just grabbed some stats and we adjusted the program to keep it within this temperature range. It begins to suffer if it goes below 50, so say if you're keeping this in your garage, it's more susceptible to temperature drop. You could maintain a higher temperature. Control the sunlight, ideal exposure is 10 hours a day. And it's not tolerant to water stress, so you would want to adjust the water dosage so it's never soggy, and also you want proper drainage, and right now that's why we have it going to the bowl, because I wouldn't want it to accidentally leak on the electrical components that are kind of exposed at the moment. Let me switch it back to that.
Yeah, I'm doing the self-cut off. Alright, so what I've done is I took that temperature sensor that is mobile and I stuck it up in a light, which is not a place to get an accurate reading of what's going on in the room, but what we wanted to show you is that just happened. The lights will shut off once we reach 95 degrees. So, handy temperature control. The secondary lights have shut off because the temperature was still really high. Oh. It'll come back in a second.
Sounds like it's resetting.
Yeah, it does sound like it's resetting.
What is it, 3?
I have no
The
idea.
plant is still thirsty.
Alright, well it's done. That was fun for it, I guess. Alright, guys. Alright.
Is something not plugged in?
So, yeah, honestly I'm not sure what it's doing. I'm gonna take this out so it stops trying to water our plants. Alright, another demonstration we could do, but probably in the interest of time we won't, is we have it so that one of the fans will shut off if the temperature goes down too low. So what we were doing before was sticking the probe in like a bag and sticking in some ice water. The temperature goes down, and then one of the fans will kick off to encourage recirculation of slightly warmer air. So, any questions?
You talked about this in the presentation a little bit. What was the specifications for when it would water the plant based on moisture level, and how high it would water it to?
Yes. So, yeah, how long it is going to water for is like just up to your discretion. Just change one line of code at Arduino. The threshold we have is, I believe, like 800 was the value. It's an analog reading, and there's not like a exact unit of soil moisture that you can correlate to the number. But what we did is basically just if it's has no conductivity, it'll read about that number or higher. And so, okay, this is actually an interesting design challenge. I'm gonna go off on a bit of a tangent. So the soil probe, because the way it measures moisture is by resistivity or conductivity. And so every time it takes a measurement, it has to run some current through the soil. The problem with that is that over a long period of time, you will corrode your cathode, I believe, or maybe it's your anode. In any case, the metal will corrode if you're constantly sampling. So I had to add in a transistor that would act as like a relay switch to turn it on so that it would be like set to measure. So that's why, well, that's further up in the program, so every 30 times that it cycles through the program, it measures the soil moisture instead of measuring it every second and then having your sensor go bad really soon. So anyway, back to threshold, cutoff, whatever. We set it at 800. That's another thing where to like a consumer, it would be left to their discretion. You get a plant, you can set it yourself, plug it in and see what the wet plant reads and set your threshold accordingly. But 800 was about where it would be super dry. And yeah, drink water. Did that answer?
Yeah, it did.
Okay, sorry.
Where did you get this fridge box?
Yeah, it is a fridge. It used to be a fridge. It was a dorm room fridge, but the compressor on it broke / was leaking, so it was just sort of a box anyway. So that's why I didn't mind hacking it into pieces. I wouldn't just
It's well insulated too.
buy a fridge to do that. Yeah. Anyone else? Things?
Does the light like automatically cut off at night or anything?
That's something we were gonna like go on to program maybe. What would probably be most useful if we we're gonna do something like that is to get a separate module that would keep track of real time. Like you can get a little battery thing that would plug into the Arduino, and that way it would actually go off or turn on rather at 8 a.m. every morning, something like that. Because if we don't have a real time module, then anytime it does something like that where it flickers and resets, then it would throw everything off. If I set it to be, on 12 hours, off 12 hours, then yeah, you know what I'm saying? It would cause difficulty. So since we didn't buy more parts to do that, this does not have a timer control built in, but that's definitely something that can be achieved pretty easily.
Okay. Good job, guys.